Hello everyone. So today we are going to discuss about the problem of largest divisible subset, which is Leetcode 368 number problem. So in this problem we have given an array and we have to find out the largest distinct positive integers of subset which satisfied the condition that every pairs is divisible by each other. So what does that mean? Like in a pair of value 1, 2, 4, 8, we can take 1 to 4 at the whole value because we can assure that 2 is divisible by 1. What does that mean? That means that 2 divisible by 1 is 0, but 1 divisible by 2 is not 0. It's like 1. So but the condition made that answer of I percentage answer of j is 0 and is the vice versa. So any of the condition meet, then it will be okay. So we don't need to consider this. And also we can see that 4 modification of 2 is 0, and also we can say that 8 modification 4 is 0. 8 modification of 2 is 0. 8 modification of 4 is also 0. So we can consider that all of the value can be the valid answer, which we are seeing in the example 2. So how we going to like approach this problem, how to think to solve this problem? So first observation is we need to sort the array. So first observation is we need to sort the array, because the array could be the array could be unsorted. Like we can have a array like 1 8 3 6 and like 2 4. We can have a array like this, so we need to sort this array first. So after that, why we need to sort this array? Because when we sort this array, we can shoot that okay, the next value will be greater than that, so we can divisible the next value after with the smallest value. And another observation is we don't need to iterate over the every value, because we can check the previous largest value that is divisible by this value, and that condition will make it. Like let's see this 1 2 4 and 8, right? So we don't first we check 2 is divisible by 1 or not. Okay, 2 is divisible by 1. Okay, that's great. We are taking 1 and 2 in our array. Then we need to check that if 2 is divisible by 4 or not. If it is divisible by 4, then we will add the array, or we will surpass the array. And also we can check that if 4 is divisible by 8 or not. If sorry, 8 is divisible by 4 or not. If it is okay, then. But here is a catch. Here is a catch. Like what? Like we can check 1 and then 2, then 5, then 15. Okay, so we have said that 1 is 2, 2 is 4, and if it is divisible by then we are okay, or we'll surpass. So what does that mean? That means that if we have so for this array we can check like if 2 is divisible by 1 or not. Yes, we can say that 2 is divisible by 1, so we are taking the value 1 and 2. Then 5 is not 5 is not divisible by 2. But is that array is the final answer? Is that array is the final answer of us? No. We can see it from here that 1 5 and 15 could be a great positive great distinct subarray. So we have to think about this point, that we have to skip a value which is not divisible by the next value. So how we counter that? Okay, so for that we can approach a brute force approach to check if this value is divisible by this or that. And if this is divisible, then we can take that. Or if this is not divisible, then we can skip that, and we can again search from the first. Okay, so by this method we can iterate over the whole array, and when the iterator or end when we are in the last index. So let us take a brief example and just take, like, we can take 1 2 7 8 and like 16, right? We can take that. We can take that reorder, but first of all, make sure that we have to sort this array. Okay, after sorting, what we can do over here, like how we can approach this problem is like in I have a thinking to solve this problem using the DPS store of the each occurrence of DPS store. So we can like issue that every index is individually a subarray. Okay, so for that we can issue that every value can have at least a point one. Hmm. And the first value cannot be one. First value can be any other numbers, not one. First value can be any other number. So we have to check that if the next value is if the next value is divisible by this or not. How can we check that? We can check and we have to check that if the previous value is divisible by this value, it has the largest DP number. What I have meant over here. Okay, I have meant that we can take an array DP. Okay, so we have taken array DP, and we have to check like if this value is if this value is if this value is divisible by this number, then we will add the previous number with the current number. The previous number with the current number. So what is the logic over here we are using? We are using like DP of I equals to DP of I plus DP of J. So what is J indicating over here? J is indicating the previous value. So we can take two pointer over here. One is indicating this and one is indicating that. It is the I and it is the J. So if DP of J, so we are taking an array DP. So if DP of J is greater than, initially we have this 0, and then we have used this as one, cause we know that every index is a subarray. Every index is individual subset, so for that we have to take here 1. So we will add this value with that. So what will be the updated value of the 2? That will be 2. Then we'll check that if 2 is divisible by 7 or not. No, it is not divisible by 7. Then we have to check from 1. Yes, 1 is divisible by 7. So we'll check, we'll also add 1. So what value we have here? We'll also have here 2. So updated array will be look like 1, 2, and it will be 2. Just giving it 1 because it is like over. Then 8 is 8 divisible by 2? Yes, it is divisible by 2. So we'll be adding the value of updated value of 2 with the value of 8. So what will be the value? It will be 3. Then so we are adding here 2, and the updated value of 8 index is 3. And then we'll check that if 16 is divisible by 8 or not. Yes, it is divisible. So what will be doing? We'll be adding 3 with this 1. So the final will be 1. So what is the highest occurrence in this array? In this array, what is the highest occurrence? This is the highest occurrence. This is the highest occurrence for. So we'll picking this index. We'll picking this value as the as our final result. But wait, how can we like how can we track the flow? How can we track the flow? For that we can take a method like we can take a 2D array. We can take a 2D array. The first will be n plus 1 because it is iterating over the whole n. First array will be n plus 1 because it is operating the whole n, and we are taking an extra index which is the base index. We'll be pointing that as a 0. We'll be pointing that as a 0. Why I'm saying it now. And we can take like two separate index row, so we are just taking 2. Why 2? The first index will be indicating the number of occurrences, or the number of highest occurrences we have, and the second will the second row will indicate the previous index of the occurrences. So 16 is pointing 16 is coming from 0 1 2 3, so 3, so it will store 3. 8 is coming from 0 1, so it will be storing 1. 7 is coming from the 0 index, so it will be pointing 0. 2 is coming from 0, so it will be pointing 0, and 1 is from 0, so it will also pointing 0. Wait, is that making any sense? No, it is not making any sense, because we have already initialized a 0, so this is the point 1. So what we can see over here, that this is not indicating as we calculated. So it is 1 is indicating 0, that means 2 is indicating at the position 1. 7 is also indicating at the position 1. 8 is indicating at the position 2. 6 is indicating at the position 4. Okay, but this is not the original array containing from this value. So when we accessing this value, we'll be adding like I minus 1 of number of I minus 1. This will, like 4 minus 1 is 3, so 3 will indicate this value, not this one. So this is the whole explanation of this. By iterating this, what we can get, that we have the first value of 16, then we can get what, 8, then we'll have 2, then we'll have 1. So this is the final output. No, we necessarily not need to sort the array. So this could be also a valid answer, which I have already submitted and it is returning true. But if we had mentioned that we have to return like a sorted array, then we can like just use the sort operation. But this is not mandatory in this case. So that's the whole explanation. Now I'm going to explain the code. Oh, I already have written the code and submitted it. So first, here we are sorting the array, then we are like just taking the number of size, and then we are taking a dp with the size, number size plus 1, and with 2 we are taking some number and indexes. I'm going to describe it later, and we are taking a vector which will be returning as the final output. So at first we are declaring the dp at first we are declaring the first value with 0 and 0. So we are declaring the 0 with the 0, and we can like change this like this, and we are iterating from 1 and 2 size, and every time we are iterating this, we are adding this, initializing this value as 0, as I have mentioned previous, that we will be initializing this as 0, every index 0, then we will add 1 in the end. So we are initializing the indexes as 0, and also the second row is we initializing as 0, because we don't know where it has occurred. It can be occurred at 0, it can be occurred at 1, or it cannot be occurred anywhere. So yeah, it cannot be divisible by any other values, so this will be pointing 0, obviously, yes, 0. Then we are just iterating a for loop from backside. So when we are in this indexes, we will be iterating from backside, that is this value divisible by is this value is divisible for this. No, this is not. Then we are just moving backward. Is this value divisible for this value? Yes, this value is divisible. So we are taking this, that if number of I minus 1 is divisible by number of j, if this value occurs, then we are also checking that if this occurrence of the occurrence of this dp value is greater than this any other occurrences or not. We can just simply calculate to understand this logic, that we can have multiple we can have multiple, like for the value of like 18, we can have multiple, what could I say, divisor. We can have multiple divisor, like we can have 2, we can have 3, also we can have 6. So we have to choose, like will we choose 2, will we 3, and will we choose 6. So on how basis we will choose that? We will choose that on the basis of occurrences of 0. So what's 0 indicating? 0 is indicating this row, and 1 is indicating this row. Okay, so yeah, and then if the condition met, then we'll update the update the first occurrence. We'll update this value with the value of the previous divisor, and we will also update the index of the value. So we are, if this value is divisible by this the previous divisor, then we are storing the indexes in here. Also we are storing the occurrences in here, all, and in the end we are just adding 1, which I have mentioned here, the 1. Okay, so, and this is the whole case, and then we just check that if, sorry, so now we just check that if the max is less than or not. We are just if this case is only to only to track the largest value. This condition is only to track the largest value. Now if the I of dp of I is greater than the maximum value, which are firstly indicating the minimum value, like -1, then we'll just update. When it's 1, it will be 1. When it is 2, 2 is greater than 1, so it will be 2. Then it will be 3, and then it will be 4. So for the position 4, what is the index? Index is 0, 1, 2, 3, 4. No, it's actually 1, 2, 3, 4, 5. We are indicating 5. Yeah, 5. Okay, so then we just take the value. First we just take this value, because this is the starting point of our backtracking. Here we are backtracking to from the last index to the first index, and then while the value does not comes to 0. Here is one more thing: when the value isn't come to 0 in this position, we just iterating over it, like is this value divisible by this, is this value divisible by that. Okay, then we just backtracking and pushing the value in the vector, and just submit the code to see if this solution works. I have already previously submitted, and this, yes, this is works, and this work with the 50% 50 ms time rate. So what is the what could I say, what is the time limit? So time limit of this problem is n square, big of n square, and the space limit of this problem is big of n. So I hope you get a I hope you get a brief idea of how to solve this kind of problem. Hope to see you soon in the next video. Thank you.